In order to start section 1.4, shifting, reflecting, and stretching graphs, we need to know the 6 common parent graph functions. The first one is y equals c, where c is a constant. That means just any number. It's going to be a linear horizontal line. So if we were to graph y equals 2, as an example, it would be a horizontal line at the 2. Y equals x is a linear equation. It goes through the origin with a slope of 1. Y equals x squared is a positive parabola opening upwards. Y equals the absolute value of x, opens upwards, and it looks like a V. Y equals radical x is part of a horizontal parabola. And y equals x cubed looks like a tangent graph. There's 2 different types of reflections. The first one is to reflect across the x-axis, and that's if there's a negative directly in front of the equation. So here we have our positive x squared, and if we wanted to reflect it, we'd just put a negative directly in front of the x squared, and it would now make the parabola concave down. For a y-axis reflection, you need the negative to be within the x term. So we have our radical x, positive, and we want to reflect it across the y-axis, we would have the negative on the inside of the radical, and so it would be going in this direction. If you do your xy table, you would be multiplying all the y values by -1 if it's an x-axis reflection, and then multiplying all the x values by -1 if it's a y-axis reflection. The next part is the vertical shrink and stretch. So this depends on what the number is in front of that equation. We're going to take the absolute value, since negative again means reflection. So if that number in front of your equation is bigger than 1, it's called a vertical stretch, meaning that you're going to be multiplying all of the y values by that number a. So the graph is going to get taller and narrower. If the coefficient in the front is a fraction, so between the numbers 0 and 1, you multiply again all the y values by that a. The graph is going to get shorter and wider. And the last part is a horizontal shift and vertical shift. So we've already seen these in Algebra 2 trig. Horizontal shift, if it's x minus c, you're going to write c units right. And if it's x plus c, it's c units left. Remember, it's like the opposite sign. If your c is on the outside of the x, this would be c units up and c units down. So there's a specific order to write all of these transformations, and you have to do it in this specific order when you're translating all of the points to graph it. The first one, you would write down what it reflects on, if any. So you'll say reflect on the x or the y axis. Then you're looking to see, is there any vertical stretch or shrink, and you tell me by what value, so by your A. Then you're going to move it to the left or to the right, so that's your horizontal shift. And last, you move it up or down, which is your vertical shift. So for example number 1, we're going to describe all of those transformations in that order. So we see that there's no reflection because it's not negative, but we do have a vertical stretch since it's bigger than 1. And it's a vertical stretch by 3. And there's no horizontal shift, but there is a vertical shift of 4 down. So we'll put 4 units down. So the 4 is on the outside of the x, it's not in the parentheses. The next one has a reflect on x-axis, vertical stretch by 2 units right, and 5 units up. And this last one, no reflection, no vertical stretch or shrink. It only has 4 units left and no vertical. Our next example is working backwards, so this time we're given a graph, and we're going to write the equation. So first you need to know what type of parent graph did this come from. So this parent graph, so that's PG, is y equals x squared, because it's a parabola. The vertex, which is the most important part, is at 2, 1. So that means it really went 2 to the right and 1 up. So we're going to rewrite that as our equation. So our f of x, if it's 2 to the right, it's x minus 2 squared, and it's 1 up, so it's plus 1. So this would be the equation of that translated graph.